Hello class, this is Mrs. Albritton of Albritton's Math Class, AMC. This video is on the study guide that we received in order to prepare for our Solving Equations quiz. So let's take a look at number 1A and B. First question asks, what's the solution to the following equations? Now keep in mind that when we were learning about solving quadratic equations, we found out that we were going to work with 5 different methods. We worked with the factoring method, the difference of squares method, we did the square root method, completing the square, and the quadratic formula. Now it is really up to the student to discern which one of those methods would be most applicable to which type of quadratic, because remember, you can't use every method with every quadratic equation. In this case, I see that the square root method would work pretty well. So let's take a look at number 1A. So what I'm going to do for 3x squared equals negative 12, the first thing I'm going to do is go ahead and eliminate the coefficient of the x squared term, which is a 3. And in order to do that, I can divide by that coefficient on both sides of the equation. So I'm going to divide this side by 3 and this side by 3. So what happens here is, of course, 3 divided by 3 is just 1, and that leaves x squared. On the other side, negative 12 divided by 3 gives me a negative 4. So the square root part comes in here. I'm going to take the square root of both sides, and that's what this means. It means to actually put a radical sign over both of the terms. And then we're going to square root both of these. So the square root of x squared, well, the square root of anything squared would be just that radicand itself. X is the radicand because it's up underneath the radical sign. Negative 4 is a radicand. The square root and the squared are inverses of each other. In other words, they cancel each other out. So the square root of x squared leaves just x equals, now I do know that the square root of 4 is a perfect square because 2 times 2 gives me 4. Also, negative 2 times negative 2 gives me 4. Because a negative times a negative is a positive. However, we learned earlier this year about negative radicals or negative square roots in particular. We found out that there's something called an imaginary number, I, that we can use in order to pull out, so to speak, the negative. So what I'm going to have here is, of course, the square root of 4 is 2, and also negative 2. But in order to account for the negative that's underneath that radical sign, with the 4, I need to use my imaginary I on both of those values. So the answer for x is 2i and negative 2i for this problem, because we have a negative radicand. Let's take a look at B. Now for this one, I can still use the square root method, even though it doesn't look exactly like that, but I can put it in that format. How can I do that? I can move this constant over to the other side of the equal sign, and I'm going to do that by subtracting 32 from both sides. Because what it does is it eliminates from being on the left-hand side. So I bring down what's left, 2x squared equals 0 minus this 32 is minus 32, or negative 32. Now I can apply the square root, just like I did up here. Oh, I'm sorry, before I do that, let's go ahead and eliminate the coefficient. Yes, because that will make the problem a little simpler. And how do I do that? Divide by 2, divide by 2. So what I have left is x squared is equal to negative 16. Now I'm going to go ahead and draw my radical signs so that I can apply that square root method. So the square root of x squared and the square root of negative 16. We've got that negative radicand to deal with again. The square root of x squared is x, because a square root cancels out a squared, equals, well, I know that the square root of 16 is a perfect square because 4 times 4 gives me 16. Also, negative 4 times negative 4 gives me 16. So I'm going to have 2 answers. I've got 4. But I've got to put my I, my imaginary I, to account for the negative. That sort of pulls it outside of the radical. And negative 4i. So there are my 2 answers for number 1A and number 1B. Let's look at number 2. All right, let's go on to problem number 2. So 2A. Here we're asked to solve using an appropriate method. And remember, we did learn about 5 different methods. And I think what we're going to do on this one right here is, first let's gather all our constants together on one side, and then let's keep this expression here so that we can start working out this problem, just to see what method would be most appropriate. So what I'm going to do is I'm going to move this constant, -10, over to this side. Of course, that means I have to do the inverse operation of -10, which is a +10. So here I'm gonna add +10. Whatever I do to one side, I've got to do to the other side. Now these will cancel out. I'm gonna bring down what's left. So I've got 2 times 5x minus 3 squared. This gives me 64. Okay, now I'm gonna go ahead and eliminate this coefficient too. The same way I did on part 1A and B when I divided by both sides. So I'm gonna divide 2 here and here. Remember, whatever you do to one side of the equal sign, you have to do to the other side. This cancels. I'm gonna bring down my 5x minus 3 squared. And here I'm gonna get 32, because 64 divided by 2 is 32. Now let's apply the square root method, because we wanna get rid of this square. That means I'm gonna put a radical sign here and here. Because whatever you do to one side on the equal sign, you have to do to the other. Now, the only thing that this will accomplish is square root of anything squared is that radicand itself. That gives me 5x minus 3. And it's gonna be equal to, now I'm gonna write this with a plus and a minus because this equals to the positive square root of 32. It also equals to the negative square root of 32. So I can write it like this: positive square root of 32 and negative square root of 32. And you can also simplify this. Sometimes the answer choices will be left here at this point. Sometimes you will be asked to simplify this. Even though this is not a perfect square, we can still simplify it because it has a perfect square factor in 32, which is 16. It also has 4 in there. 16 is the biggest one, that's the one we would use. So I'll show you that method also. But from here, what I can do is I can go ahead and let's split it up into the 2 problems, because remember, we're gonna have 2 answers for most of these quadratics. And since we've got 5x minus 3 is equal to a positive square root of 32, it's also 5x minus 3 equal to a negative square root of 32. So we're going to do, I'm gonna write both problems. The first one will be 5x minus 3 equals to just positive square root 32. And then the other one will be 5x minus 3 equals to the negative square root 32. So when I solve for x, that just means eliminate everything else. So I'm gonna do inverse operations on each of these. Bring down my 5x equals, I can't combine these because they're not like terms, so I just bring them down. So I'll bring down 3 plus square root 32. Not done because I still gotta divide by 5. You need to get the x isolated. So that means the 5 has to go. It cancels. So on this side, or this first answer, x is all of this. 3 plus square root 32 divided by 5. Now let's do the same here. It's almost identical. We've got plus 3 on both sides. All right, that cancels to 0. You drop down your 5x equals, I can't combine these, so it's 3 minus the square root of 32. And then the last step, in order to isolate the variable, divide by the variable's coefficient. Which, whatever you do to one side, you have to do to the other. So here we got x is equal to 3 minus the square root of 32 over 5. So here's our 2 answers. And if you simplified your square root of 32, which you can do because sometimes the answer choices will require that, then you may have gotten, this is an alternate answer, x is equal to 3 plus 4 radical 2 over 5, and x is equal to 3 minus 4 radical 2 over 5. So how did we get 4 square root of 2? Because we can break the square root of 32 into radical 16 times radical 2. And of course, the square root of 16 is 4, and you keep the square root of 2. So this is how you may end up with that alternate answer, which is also correct. All right, let's look at 2b.